This is a proof from Euclid's Elements, Book 1, Proposition 16, the exterior angle theorem. This theorem says the following. Given a triangle ABC, extend the base BC to another point D, and the angle ACD is greater than any of the interior opposite angles. So this angle ACD is larger than the angle of the triangle at B or at A. To begin this proof, we start by bisecting the segment AC. We call that point E. And then we'll draw a line passing through the points B and E. And then we'll create another point on this segment whose length is the same as the segment BE. Next, we'll connect C and this new point F, and then we'll observe that we actually have two congruent triangles, triangle AEB and triangle CEF, as follows. We know that the segment AE is equal to the segment EC because E bisects the segment AC. We know that segment BE is equal to segment EF because F was chosen so that EF was the same length as BE. And finally, we know that angle AEB is equal to angle FEC because vertical angles are equal by proposition 15. Therefore, triangle AEB is congruent to triangle CEF. We're particularly interested in the following two angles being equal. The angle BAE and angle FCE are equal because angle ACD, the exterior angle of the original triangle, this angle is larger than angle ECF, and ECF in turn is equal to one of the interior angles for triangle ABC. So this exterior angle, ACD, is greater than this exterior angle. Now, to prove that the exterior angle ACD is also greater than angle ABC, the other interior angle of our triangle, we first extend the line from A through C and create a point on this line. We'll call it G. Now the angle ACD, the angle BCG, these two angles are vertical angles and therefore they are equal to each other. To show that ACD is greater than the angle at B, it's equivalent to show that angle BCG is greater than the angle at B. And we can achieve that using the same construction as we did previously to show that angle ACD is greater than the angle at A. Again, we can construct the midpoint of BC. We can draw a line through this point. Then draw another point on this line such that HI is equal to AH. And then we can obtain a second pair of congruent triangles. We'll connect these points right here. And then we'll have another pair of congruent triangles. BH is equal to HC, AH is equal to HI, and these two angles, BHA and IHC, are equal because they're vertical angles. Here we've recolored the parts of the two triangles we're interested in. So by side angle side, we have triangle AHB congruent to triangle IHC, and since corresponding parts of congruent triangles are congruent, we know that the angle at B, the angle ABC, is equal to the angle HCI. Therefore, the angle at B is less than the angle BCG, which is equal to the original exterior angle ACD. Therefore, we've shown that the exterior angle ACD is also greater than the angle ABC. This completes the proof that the exterior angle ACD of the triangle ABC, the exterior angle is greater than either of the two interior opposite angles.